here are the first 5 terms of a quadratic sequence. Write an expression in terms of n for the nth term of the quadratic sequence. So I'm just going to rewrite it. So I've got plenty of room. 5, 10, 18, 28 and 40. And we need to find the second order difference. Let's find the first order difference. So plus 6, plus 8, plus 10, plus 12, which means that my second order difference is plus 2. So we know that whatever the second order difference is, we halve it to get our coefficient of n squared. So if it's 6, we would have 3n squared. If it's 10, we would have 5n squared. Here it's 2, so we're just going to be using n squared. So I know that this sequence has something to do with n squared. So I'm just going to write out how many terms I'm going to use. 1, 2, I'll just do 4. You can do 5, you can do however many until you notice the pattern. And we know it's something to do with n squared, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And then I'm going to write my sequence down. And my sequence is 4, 10, 18 and 28. So now I need to see, is there a relationship between the n squared and the sequence? Is it quite obvious? So how do I get from 1 to 4? Well, it's plus 3. 4 to 10 would be plus 6. 9 to 18 would be plus 9. And then 16 to 28 would be plus 12. So it's not the same for each one. So it's not just going to be plus a number. We're going to have to look at if there's a pattern within those numbers, which I'm going to write out the numbers again. So those that black sequence there. So 3, 6, 9, 12. And that is obviously the 3 times tables, so that's just 3n. So to get from this row here to this row here, what we've effectively done is we've added 3n. So altogether we've got n squared plus 3n. And that's my final answer.